Piecewise equations.
Same one as yesterday. How long are the notes for this?
Took me 2 fronts. Okay.
23rd.
23rd.
September's almost over. Oh my god.
Piecewise function, right, is an equation with 2 or more, I would say pieces because it's piecewise, but we'll say 2 or more parts. Okay. So one thing to remember here, we did say that it was a function. That means that x cannot repeat. Okay, so I'm going to show you what it looks like. We're going to write f of x and in equals, and then the curly brace is going to be 3 lines tall. Now, we just reviewed graphing linear equations, and if I look at the board over there, I left the formats up. One of those particular formats is mx plus b. Notice that the f of x or the y equals is outside the bracket, equals y equals mx plus b. That's the first piece or the first part. So then we're going to write a comma. And then I'm going to write domain. This is the domain of that line. It's only part of a line. It could be an array. It could be a line segment. Okay? So I'm going to switch colors. Then maybe I have something written in point slope form. Notice that it's the red part there. I solved for y, so I moved that y1 to the other side, comma, domain. What was the question? Okay. Just because I was trying to make my comma not look like it was attached to the 1. Just, that's it. Okay.
Wait, so if it was written, it would be like an equation, comma, then the domain?
Yes, it would. Okay, so another part could just be y equals a number. These are in y equals format. It has to be solved for y. Comma, domain. Now, the domains here are typically written as an inequality. Okay, remember we had those different notations, interval notation, set notation, just writing inequalities. The domains are usually written with an inequality. Okay, so in this particular example, we have a blue part, a pink part, and a green part. 3 parts. Each of them have their own specific domain. We're going to look at how to evaluate a piecewise equation. First thing we do is check the domain. That's this part. Second thing we do, plug in to corresponding part. Corresponding part. Right, this is x comma y. This is just talking about points. X's and Y's. Finding the right points.
Can I use a whiteout?
Okay. Example.
Are we using a sticky?
Nope, not yet. The sticky will be in part C. I know. They're fun. Okay, so here comes my piecewise equation. So I'm going to use 3 colors. I'm going to highlight it just because I'm writing in the blue pen. So the first one will be 2x plus 5, comma, the corresponding domain. So that's the linear equation, 2x plus 5, but it's only good for this particular domain. X is less than negative 2. That's it. Okay, I'll do the middle piece here. Now, the formats, it can be any mixture of these formats. It doesn't have to be specific. It could be any of them. They could all be the same. They could all be different. Okay, so this time, comma, x equals negative 2. And then I'll do a third part. Oh, I didn't need those. Okay, comma, negative 2 less than x less than or equal to 6. Whew. That's it. That's my piecewise equation. This one has 3 parts. Okay. I'm just going to highlight, so I'm going to do pink, just defining colors here. I'm going to do the middle one, is going to be orange. Okay, and I'll do the last one green. Okay. Now you've never seen a piecewise graph. So before we get into evaluating it, I'm going to use Desmos to just demonstrate what this graph would be.
Can we close the bracket?
No. I've seen the bracket close, but typically no. This is just sort of listing the 3 pieces. Okay. Close. All right. I'm going to scooch this up so we can see it. So this is what I'm trying to graph. So I'm going to graph it in 3 parts. 3 parts. First, I'm going to do y equals 2x plus 5. mx plus b. But then I have to restrict the domain. So I'm going to do a curly brace. X less than negative 2. Notice how all it did is it just took the same line and it just cut it off. And it's only to the left of negative 2. Now Desmos is awesome, but it doesn't actually do this exact format. I have to do it in 3 separate lines. So let me go ahead. I'll change this one to, red so it sort of matches. Okay, now I'm going to do the orange one. Y equals negative 2. There is a little video on Schoology that shows you how to do this if you're interested in looking at it again. Okay, bracket, x equals, okay, so there's the line. Okay, you see it? I'm going to make it orange. Okay, and if this is supposed to be at x equals negative 2, that's right up here, right there. See that? That's the point, negative 2, 2. That's the point on the graph that is corresponding to that domain. Fortunately, the domain, when I write this, Desmos is not good at plotting that point, so I'm going to plot the point for it. Okay, and I'll make it orange because that's what it's supposed to be. Okay, now I'm going to do the last part. Y equals 2/3 x plus 4. Okay, so there's the whole line. There's the whole line, but I need to fix the domain. Okay, I'm going to make it green. Okay, and I'm going to change the domain to -2 less than x less than or equal to 6. Okay, I'm going to zoom out just up. There it is. So now we can see. There it is. Okay. That is the piecewise graph. All you're doing is you have each of those equations that only matches a specific domain. Okay? Now, as we're looking at this, I want to show you something because Desmos doesn't do everything perfectly. Okay, notice here, x is less than -2. That's a not included endpoint, just like we did with domain. That's not including the endpoint. Here, okay, this is also not including the endpoint, but this one is included. So there's a few things that Desmos can help you with, but you also have to understand and interpret what those statements are saying, okay? So that's a piecewise graph. Different pieces, specific domains. So now we're going to evaluate. Here. Okay, I'm going to make a little 3 columns, 2 rows. Okay.
How big should they be?
3 lines tall should be sufficient. Right. And I'm just going to put a couple different statements here, and we're going to evaluate one function a couple different times.
Can you move it over a little bit? Like, what is before that?
Oh, yes, there you go.
Is there a reason there's a dot before the end?
No, I'm just like, instead of counting, I'm just
Oh,
like a bulleted list.
okay.
That's it. Okay,
This is supposed to be. Oh, never mind.
there you go. Okay, so I'm going to read my directions. It says, check the domain. Okay, so this is x equals -3. That's what this notation means. So as I'm checking my domain, I have to pick which domain this -3 fits into. Pink, -3 is less than -2. So I've chosen the pink domain. Second step says plug into corresponding part. Okay, that's the pink part. So I'm going to plug in to the pink part. And I get -1. Okay, that's how you, there's one answer. This is a function. Each x has exactly one y value. This is the x and the y point. This is the function notation at the top. Okay. Now time for you to participate. Lots of questions. Which domain does x equals -2 fit into? Okay, Jane? Orange, yeah. Right there. Right there. See that? It's orange. Okay. Somebody else. What am I going to plug into? Say it here. Okay. Yep. So to this orange piece right here. Just be careful with your pluses and minuses. Okay, so I get 2. And so the point is -2, 2. I want to make sure that you recognize this is just x comma y points, just the notation's a little bit different. Okay. Third one. X equals 3. Somebody new? What domain does it go with? Yes, Victoria. Green. Fantastic. Okay, so now that I have the green domain, somebody new, what am I going to plug into to find the y coordinate? Yes, Harrison?
Plug it into the x.
Plug it into the x. Yes. Which equation am I using?
The green one.
The green one. Okay. Okay, so this is 6 over 3 plus 4, so that's 2 plus 4, so that's 6.
Can you scoot it over?
Yes, I can. Yep. All right. Here, got this. There we go. Now we can see it all. Okay. Yes.
Did not do anything with the right side?
What do you mean the right side? This?
Yeah.
That was the first step.
Okay.
The domain is the first thing that I checked. This is not comparing anything to the y value. This is just listing the domain where I will use each of these y coordinates. Okay. 1, 2, 3. You pick. New person. You choose which one you want to do first. Yes. This one? Okay. What do you want to tell me about it? Yes. Okay. X equals 7 doesn't fit anywhere. 7 is more than 6. So it doesn't work. This is undefined. There is no definition. There's no equation that goes with it. So there's nothing there. Nice job, Olaf. Okay. Somebody new. Your choice. Anyone you want to tell me about? Wait. Nope, you already answered. Somebody new. Yes.
With the second one being pink.
It could also be green.
Nope. Pink is correct. It's a function, guys. The x's are only going to go in one place. Okay, so why do you say pink? Uh-huh. So one thing that could help you with the domain is you can put them on this horizontal number line, and you can sort of think of it this way. -4 definitely fits in here, where this is the pink portion. This little dot right here is the orange, and then this part right here is the green. Yeah, so if you're kind of stuck on where the domain goes, you can think of it on that number line instead. Okay, so -4, what am I going to evaluate with? Yes, Lee. Yep, 2x plus 5. Fantastic. Notice that by evaluating, we're just coming up with xy points. All right. Last one. Have you answered? Yes, somebody new. Okay. Okay, right here.
Like the last one being green.
Yes, it would be green. Okay, so 6. Notice, yeah, that's filled, right? The 6 is included. Okay. Somebody else? What am I going to plug into? Okay, Ethan? Yes, so 2/3 times 6 plus 4, so we get 12 over 3. It's 4 plus 4. is 8. That's my point. Whew. Okay. Okie dokie, 0. 0 fits nowhere. 0, yeah. Nope, not here. Not here. Undefined. Okay, new problem. You're just going to hold up the answer, whatever it evaluates to. Okay. F of 2. I can zoom in a little more. Yes, yes. Yes, 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 yes. Yes, yes, yes. Uh-huh, uh-huh. Fantastic. Uh-huh, yes. Yay! Look at that. You thought Piecewise was going to be hard. It's not. See you after lunch. We'll continue. Evaluate. Evaluate and then hold up your answer. Yes. Yes. All right. Evaluate and then hold up your answer. There is. There's an answer. Oop, yes. Yeah. Okay, then yes. Yes, 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 yes. All right. So here, this is saying that x equals 4, which fits here. And so the outcome is actually y equals 4 also. Okay, let's do another one and make sure that we've got this. Okay. Okay, there you go. Okay, evaluate and hold it up. Yes. Yes. Yes, yes, yes. Look at that, you guys are learning. Yes, yes, yes. Yes. Yes, yes. 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 If your markers are dying, just come switch them out. I have a whole handful of them up here. You can just come trade them. Yes. No. Yes in the back. Yes. Here's more markers if you need them. Just come grab them off the list. All right. Last one. Okay. I want to see everybody respond. No, not that one. Hold on, I'm getting there. Sure. Okay, here we go. Let's do this one. Okay, last one. Evaluate. Oh, hold on a minute. Yes, yes, yes. Yes, yes. Yes, yes, yes. Yes, 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 yes. No. Yes, 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 yes. Yes, 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 yeah. Yes, yes, yes. All right. So, right here, this is the x coordinate, which is this one, right? See this? 0's not included. Okay, so then you plug in 0, and you get -4. That means the point is 0, -4. So if I put a 0 here, it only goes into this y value. All right. Nice job. So now we're going to flip our page. Okay. And we're going to create the graphs. Okay. So this is where our little stickers are going to come in. Okay. We're actually only going to use 2 stickers today. So if there are extras, you just leave them there because 8th period is going to use them also. Okay, we're going to put a little bit of writing at the top, and then we'll just have 2 stickers here towards the bottom right of our screen. Okay, so we are going to graph piecewise. Okay. One of the things you have to consider is the domain. Okay, that's kind of always the first thing that we're looking at is the domain. Well, when we are graphing, the domain is what corresponds to the potential endpoints on the graph, right? We may have line segments, we may have rays, which is a point and an arrow, okay? And the domain is going to tell us whether these points are closed or open. Forgive my spacing. Closed or open.
Do you need to white out?
Yeah.
I still have this.
Okay. Second thing we're going to do, okay, domain, endpoints, closed, open. Okay. Endpoints is sort of the big one here. Second thing we're going to do is graph the lines. That's it. Graph the lines. Now, with this, I'm going to say check domain. Domain is really important when you are graphing the lines. Okay, and when I say check the domain, left or right, we're looking to the left or the right to make sure that we're graphing the line in the right direction. Okay. Okay, here comes our first example.
Do we need one of those stickers?
Okay, here we go. So my sticker, these are pretty nice because they're a little bit bigger than the Post-it notes. They do have positives and negatives, so just sort of check your graph and make sure that you're orienting it correctly. All right, we're just going to do it like that. Okay, there we go. Example. Yeah, pass them around. There should be some extras.
I have some extras from last class.
I mean, you can use them or just, we're fine for now, I think. Okay. F of x equals, okay, so we're going to do 3 pieces. This one is x is less than or equal to negative 2. Okay.
Negative x, right?
Yes. Okay. Negative 2 less than x less than 3. Okay. Okay, there we go. I'm going to color code so that it's easy to distinguish which pieces we're talking about. Go pink, yellow, and green. Okay. And I'm going to go back and I'm going to look at my directions. The first one says, look at the domain and determine your endpoints, whether they're closed or open. So I'm actually going to make a table over here, which is the evaluating that we just did. Right? We plugged in points. Okay, that's what we're going to do. However, I have 3 pieces. And so I'm looking at the domain for the endpoints. Negative 2, negative 2, 3, 3, 6. I need endpoints for all of these segments. So I'm going to put negative 2, dot, 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 because I'd like to divide up the sections. And negative 2, see how it's included? That's a closed point. So I'm just going to put a little note to myself. That's a closed point. This is for the pink portion. Okay, right? That is the pink endpoint. Now I have two endpoints for the yellow section, -2 and 3. Except this time, see how they're both not included? That means that they're going to be open points. Now I know that -2 is in this table twice, but notice how it's actually only included once. It's important that it's only included once. Okay, I just do the dots in my table to help break up the different sections of the graph that I'm looking at. Okay, so now I have two more endpoints, 3 and 6, and these actually both happen to be open as well. Okay, so this is for the open or closed. All right, we know how to evaluate. Let's evaluate and fill in the y coordinates. Okay, make sure, right, we've picked out the domains. Let's plug into those corresponding parts. Negative. So that's a -3.
Wait, how did you?
Right, because this is the pink part, so I plugged in.
Plug in the endpoint?
Yeah, I plugged in -2 to the pink part.
Oh.
Right, I evaluated. Now the yellow part, there wasn't anything to plug into, so the result was just -4. Okay, so now I'm going to do the 3 and the 6, and they're both green. I know they're open points, but they're open points that correspond to the green piece. Okay, so let's do a little plugging in.
Will you do it twice?
Yeah, so this time I'm just going to have to plug in twice. So this is -4. And this is 2.
Why did you plug in one?
I didn't plug in 1.
Margo, can I-
3 minus 2.
One.
Yeah, I just did the first step in my head. Okay. We're going to graph one section at a time. I like to go left to right, but you can really do it in any order that you want.
You do it one time.
I can.
For open and closed, having which side?
Say that again.
For open and closed, having which side of the
Okay, so we'll see where it shows up when we start plotting it and drawing it, because when we start graphing the lines, we're going to check our domain again and make sure that we're going in the right direction. Okay, so we're going to start by putting the point -2, -3 closed on the graph. Okay, there's my point. -2, 3 on the,
Isn't it negative?
it is -3.
Oh, here.
Where are my whiteout
Negative,
pens?
negative.
Hold on, I put it in the wrong place.
Nice pen.
Here, why don't where's yours?
I got it, I have another one. Oh man, whew. Crisis averted. Okay, there it is. -2, -3, let's try that. Okay, now, look at the pink equation. This is y equals -x minus 5. How do you graph y equals -x minus 5? You plot a point, Jane.
So since it's, so you go to, you have to go -5,
Mm-hmm.
and so then it's just, the slope is just -1.
Uh-huh. So that would be start at -5. However, I can start anywhere I want. I happen to have a point already. You can just count the slope from there, right? You can count the slope from any point on the line. I happen to have an endpoint. Now, be careful. Do I need to count my -1 slope to the left of this point or the right of this point? To the left, because x has to go less than -2. That's why it's tricky, guys. You gotta count your slope to the left. Make sure you count a -1 slope to the left of your starting point. Okay, this is where I happen to be starting, and I'm gonna count my negative slope from there.
How do we know the slope?
Look at the equation, y equals -x minus 5. Okay, whew, got it? It's not the graphing of the lines that's tricky. It's the endpoints, and to the left and to the right, and making sure everything is corresponding. Okie doke. This is the pink part. Okay, so I graphed the line -x minus 5 with this domain only. Check that out. And there's that -2 to the left. Okay, now we're going to do yellow. Notice that you have 2 points just because of how yellow was defined. 2 points makes a line. Plot them, connect them. Okay, so -2, so this is open. 3, open. It's linear. Oh, that's a horizontal line. These 2 pieces is just y equals -4. That's a horizontal line. Okay. Okay. Next, I'm going to do the green part. And I have 2 points that are open. 3, -4. It's okay if they end up in the same place. It's okay. Open. 6, 2. All right. Now, looking at the green line, okay, check the format. This is x minus x1, y1. The slope is 2. Right? Look at the format of the equation. In this particular equation, the slope is 2. You could count your slope from the point between 3 and 6, so to the right of 3 and the left of 6. And notice that the slope actually does connect the endpoints here. And connect. Now this is just a line segment, right? Because it's got 2 endpoints. Make sure that stays open. Okay. Okay, and so this is the green part right here with a slope of 2. Notice that as you drag your vertical line across the graph, it is a function. Piecewise function. All right, so let's see if you can do the domain and range of this graph. Okay, that's what I need to fill in. I know there's 3 pieces, however, some of it overlaps just a tiny bit. Anyone know what might go in one of those parentheses? Okay, I heard a negative infinity. Yep, we can start there. Okay, I'm going to drag my pencil. Look at where negative infinity, so included, 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 included. Whoop. Okay, hold on, wait, negative 2 is included, and then I bump down here to the yellow piece, included, not included. Because I'm still touching the graph as I drag it across. I just happen to be switching pieces here. Okay, it isn't continuous because you have to pick up your pencil, but the domain, it's just listed like this because at that negative 2 spot, the closed point sort of overlaps the open one there when you're just looking at the x's. Now the next piece is just 3 to 6. Notice how there is nothing filling in via x equals 3. That's why that one is not included. Soft brackets on both of them. Open circle, not filled in. And infinity is always a soft bracket. All right. Okay, last example. Oh yeah, sorry. Yes, range, here we go. Okay. Range, I'm gonna drag the horizontal line across the graph. Okay, so right here, bottom to top, I'm looking at negative 4. But notice how the open point says not included, but the solid line says included. So negative 4 is included. Okay, notice here that I'm not touching this gap, but the green line is. Okay, we go up, up, up. Then I get here. This y value looks like it's not included. However, I am touching the graph in 2 places, and the 2 is included on the pink. Included. So the range is actually negative 4 to positive infinity. You have to put them in order. It's always negative to positive. Yes. Okay, so you see the yellow line? That's a bunch of included points. Okay, so the included sort of overtakes the open point. All right, here we go. All right, think about the words that I used to explain this. I'm going to give you a little start, a head start. See where you might get stuck in terms of what you're doing to graph this piece here. Okay. We'll go with 2 pieces. Okay, here you go. That's what you're graphing. Pink and yellow.
Pink is at the top.
Yep, pink is on top. Good question. Pink and yellow.
The words?
That I'm using. Okay. The first thing I'm going to do is look at the endpoints of the domain and decide whether they're open or closed. Okay. Now I'm actually going to plug in and get the endpoints. Okay. Negative, negative. So we get 4 plus 2, so I get 6. And I get 2. All right, now as I'm trying to graph the pink line, I look at this, and this is the line I'm trying to graph, right? That's the line I'm trying to graph with this specific domain. The slope is negative 1. So I'm going to go negative 4, 6, open, 0, 2, closed. And notice that when I connect those points, I'm counting my slope to the left of 0 or to the right of -4. It's a -1 slope. Okay. Right, there's lots of ways to graph a line. Connecting endpoints is one of them, but counting the slope is the other. Notice here that you could have started at a +2 intercept and counted a -1 slope. Yeah? Yes, Pink.
Isn't there a -4 for?
Say that again.
Oh, wait, no, never mind.
Yeah, oh, yep, commas, commas. Okay, you're good now? All right, now I'm going to move on. I'm going to do the yellow part. Okay, so I got pink. Pink happens to be a line segment. Yellow endpoint only has one endpoint. Okay, and this one is open. Okay, so this is -1. So that's right here. Okay, now this one only has one endpoint. Yes, Ethan. Okay, so this is the equation that I'm trying to graph with this particular endpoint. Means I need to count my slope of 2 to the right of 0. And however far you count it, just make sure you put an arrow on the end of it, because it keeps going. Okay, we are going to do the domain and the range, just because I like to practice those skills, because now that we've got graphs that aren't so continuous, it gets a little bit trickier. Okay, so I start with my domain and I'm going left to right. So I got -4 not included. Okay, I'm just dragging my pencil across. Okay, solid lines are included points. Include, 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 include. I wish I could do that Mario sound when you go into the tubes. Okay, I come down here. Notice, the x-coordinate of 0 is included on pink, but excluded on yellow. It's still included. Move on. Included, included, included. Positive infinity, open. All right, and then I drag my horizontal line. All you're trying to do is touch the graph at least once when you're describing domain and range. So 1 not included. Boop, boop, boop. Okay, still included, not included. However, on yellow, it is included. So it's included. Yes. Thank you. Whew. Okay, here we go.
So then it will be due on Monday.
Monday night. So after we have time in class. All right, so here's what I would do. I would still get out my paper and I would write these things down as I'm doing them, because that's how you practice. Dot, 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 and 5. Oh, 6. Okay, so this is me on my paper. Okay, and then I get a +6 slope. Doesn't really count this way very well, so 1, 2, 3, 4, 5, 6. Okay, look at that, guys. +6 slope. Okay, 5, 2, open with a 1 slope. All right. Now I'm actually going to click the buttons and do it. Okay, so let's see. Click and drag to make a line. Click the line to delete it. Click on an endpoint of a line to change it. So I'm going to click here, click and drag. Okay, so there's my, right? I feel like this needs to be open. Okay, I'm gonna erase this part because I've got this. Now I do need to have an arrow, so I'm just gonna keep clicking it and see if I get an arrow. Oh, there it is. Gave me an arrow. Great. Now I'm gonna click and drag a one slope. Okay. This is why you do it on paper, so you're just transferring it. Otherwise, you're gonna learn it better if you do it on your paper first. Okay, so now I'm going to change my endpoint, and you gotta get the arrows in the right place. Okay, and submit. Uh-oh, what did I do wrong?
The math teacher got
I know. Oh, you know what? I counted my slope of 5 instead of a 1. Except you get 2 chances, so you get a chance to fix it. This is not the actual assignment.